Hey everyone, I already discussed 1NF and 2NF. Next I will discuss 3NF. In 1NF, every attribute should be atomic. In 2NF, there should not be partial dependency. In 3NF, there should not be transitive dependency. What is transitive? If A implies B, B implies C, then A implies C. Suppose there is this kind of relation, this kind of dependency, then we should separate B, C from A, B. If transitive dependency exists in 2NF, we should separate that and make another relation for the transitive dependency. And while doing decomposition, two following properties should be preserved, that is lossless decomposition and dependency preserve. First I will discuss lossless decomposition. When we are doing decomposition, there should not be any loss of dependency. Suppose R be a relation and F is a functional dependency, and we are splitting R into R1 and R2 in such a way that their join should be R. Okay, then we can say it is a lossless decomposition. The decomposition is lossless decomposition if there is no loss of information by replacing R with two relation R1 and R2. Means after decomposition there should not be any loss of information, then it is a lossless decomposition. Suppose we have R and we are splitting into R1 and R2, their natural join should give us R. So R1 natural join R2 should give us R. If it is not giving us R, then that is a lossy decomposition. In other words, we can say when we are dividing R into R1 and R2, their natural join should give us R. If it is not giving R, means that is a lossy decomposition. So decomposition that is not lossless decomposition called a lossy decomposition. If no loss of information, then that is a lossless decomposition. If there is some loss of information, then that is a lossy decomposition. Let's see this example. We have R, R1, R2. We split R into R1 and R2. Now we'll do natural join of R1 and R2. So A1, B1, B1, C1, then A1, B1, B1, C3. For A1, B1, there will be two rows. Okay, A1, B1, C1, A1, B1, C3, then A2, B2, C2, then A3, B1, C1, A3B1 C3. R is a subset of their natural join. R is not equals to R1 natural join R2. So after join we are getting more rows than R. So R is a subset of this join. That's how we can say this is a lossy decomposition. Here R not equals to R1 join R2. And this method is time consuming when we are taking every single value. So that's why we don't consider every single value. We just go with attributes. There are two ways. One is insertion and another is table method. Let's see some example where we can use insertion and table method and we can check whether it is a lossless decomposition or lossy decomposition. Now example 1, I already discussed same example for checking 2NF. Now we'll check 3NF and lossless decomposition. We have a relation and functional dependency. First we need to check 2NF. For 2NF there should not be partial dependency. So first we'll remove partial dependency. There will be three tables A, D, E, I, J, B, F, G, H, A, B, C in 2NF. Okay, now in 3NF here BF FGH. BF will be in one table, FGH will be another table, that is transitive dependency. For transitive dependency we should separate, and ADE will be one table, DIJ will be another table. Okay, that is transitive dependency. Now we'll remove the transitive dependency from R1, R2, R3 will be same, ABC. R1 will decompose into two tables. One is ADE, another is DIJ. R2 will decompose into two tables, BF, FGH. So ADE, DIJ, BF, FGH. R3 will be same. In 2NF there was three tables, three relation. In 3NF there are five relation. We decompose R1 and R2 into again two relation. Now we'll check this 3NF decomposition is lossless or lossy. So first we'll check the insertion method. ADE, DIJ, it will be A, D, E, I, J, then B, F, F, G, H, B, F, G, H. Now merge these two, so it will be A, B, D, E, F, G, H, I, J. Then A, B, C merge, so we'll add C here, A, B, C, D, F, G, H, I, J. Yes, this is lossless. We got all the attribute. This is insertion method. We are just merging two to table and finally merging all. That is insertion. Next we'll check table method. We'll take relation in left side and top all the attribute. Now R11, that is ADE, we'll write ADE. Next R12 DIJ, DIJ. When D is there, we'll copy all the attribute that is with D in previous row. So A and E will come here. As with D, A and E are in previous row. Next 21 BF, then R22 FGH. Now we'll copy B here as B was in previous row. Next ABC. So A, B, C. Now with A, we'll write D, E, I, J. With B, we'll write F, G, H. So all the attributes are in last row. That's why this is a lossless decomposition. In table method, according to relation, we'll fill the row. Whenever any attribute is repeating, we'll copy all its row data, and in this way we'll continue. If we are getting all the attribute in last row, then this is a lossless decomposition. Let's see another example. Example 2. We have a relation and some functional dependency. Now in 2NF there will be A, F, C, D and B, E. There will be 3 tables. A, C, D, F 1 table, B, E 1 table and A, B. There should be 1 table that contain all the key. Now in 3NF, this CD will separate from A, F, C, as this is a transitive dependency. So only R1 will decompose. R1 will be ACF and CD. R2 and R3 will be same. So now we'll check whether it is lossless or lossy by the table method. First relation R11 contain ACF. Next is CD. When we are writing C, we need to copy A and F. Okay, so here there are A and F. Next R2 B, E. Next R3 AB. When we are writing A, we should copy C, D, F. When we are writing B, we should copy E. Now we got all the attribute, hence it is a lossless decomposition. Next another example, example 3, we have a relation and some dependency. We need to find the third NF and check whether it is lossless or lossy. In 2NF, there will be ABE in one table and CD will be in another table, AC will be in another table. So there will be total 3 tables, ABE, CD, AC. Now in 3NF, we'll remove the transitive dependencies. So BE will separate from AB. This is a transitive dependency, right? AB will be in one table, BE will be in one table. R2 and R3 will be same. Just R1 will decompose into 2 tables. R11 BE, R12 AB, R2 and R3 are same. Now we'll check this 3NF decomposition is lossless or not. Let's make the table. So first we'll write BE, then R2 CD, then R12 AB. When we're writing B, we should copy E. As in R1 one row with B there is E, so we'll write E here. Next R3 AC, with A we'll write B and E, with C we'll write D. All attributes are here, hence this is a lossless decomposition. Now I'll check the last example, example 4. Now in 2NF there are 5 tables, 5 relation. ABC, BDEF, ADGHJ, AI, ABD. In 3NF, we'll remove the transitive dependency ADGH, HJ. We'll remove HJ from ADGH, and rest all will be same because all are from the one functional dependency. So just R3 will split, R3 will decompose into 2 relation ADGH and HJ. Okay. In 2NF, we are removing the partial dependency. In 3NF, we are removing the transitive dependency. And there was just one transitive dependency. Next, we will check whether this is a lossless decomposition or not by table method. You can also do the insertion method. Just combine 2 relation and finally combine all. If you are getting all the attribute, that is a lossless decomposition. Write all the attribute in top and write all the relation in left. So R1 A B C, R2 B D E F, with B A and C are there, so we'll write A and C here. Next R3 1 A D G H, with A B C D E F are here, so we'll copy B C D E F. Next R3 2 H J, with H all are here, we'll directly copy all A B C D E F G. Next R4 A I, with A all are here, okay, except I, so we are writing all, we are copying all, and here already I is there. Next R5 A B D, already in R4 all attributes are there, so just copy. With A B D all attributes are attached, so we'll write all the attribute. As we are getting all the attributes, so this is a lossless decomposition. In today's lecture, I discussed what is 3NF, how to check lossless decomposition. In next lecture, I will discuss dependency preservation, how we can check whether one decomposition preserve the dependency or not. In 1NF, every attribute should be atomic. In 2NF, there should not be any partial dependency. In 3NF, there should not be transitive dependency. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.